Hello and welcome to another segment on determinant. Today we shall be discussing about properties of determinant that help us out in evaluating the values of determinant in much simpler way. After that, we shall conclude the lecture by discussing some problem that would be based on the usage of properties of determinants. Now beginning with the properties of determinant, determinants have some properties that are useful by the virtue of the fact that they permit to generate equal determinants with different and simpler configuration of entries. This helps us in determining the values for the determinants in a much simpler manner. Now starting with the first property of a determinant, which states that if each entry in any row or each entry in any column of a determinant is 0, then the determinant is equal to 0. Now we are going to consider an example and will prove it. Now according to this property, the given determinant whose first row consists of 3, 1 and 5 as its element, the second row is entirely of zeros and the third row consists of 2, 4 and -2. Now according to this property, the value of this determinant should be equal to 0. Now we are going to prove it by expanding the first row on the left hand side. Then the left hand side becomes 3 into 0 into -2 minus of 0 into 4 minus 1 1 into 0 into -2 minus of 0 into 2, then 5 into 0 into 2 minus 0 into 4. This gives us 3 into 0 minus 1 into 0 and 5 into 0, which finally leads us to a value of 0, which is equal to right hand side. Hence we have proved that if each entry in any row or column is 0, then the value of that determinant is equal to 0. The second property of a determinant states that if rows be changed into columns and columns into rows, then the resulting determinant is unaltered. For this, we are going to consider an example of third order determinant in which we have interchanged the rows into columns and columns into rows. Now we are going to prove it by taking left equal to the determinant obtained from the determinant 1, whose determinant value would be given as by expanding the first row a1 into minor of a1, which is b2 c3 minus b3 c2 minus a2 into b1 c3 minus c1 b3 plus a3 into b1 c2 minus b2 c1. Now expanding it further, we have left hand side as a1 b2 c3 minus a1 b3 c2 minus a2 b1 c3 plus c1 b3 a2 plus a3 b1 c2 minus a3 b2 c1. Now expanding right hand side equal to expanding the first row of determinant 2, we have a1 into minor of a1, which is b2 c3 minus b3 c2 minus b1 into minor of b1, which is a2 c3 minus a3 c2 plus c1 into A2 B3 minus A3 B2. Now expanding it further, we have right hand side as A1 B2 C3 minus A1 B3 C2 minus B1 A2 C3 plus B1 A3 C2 plus C1 A2 B3 minus C1 A3 B2. As we can make out that the left hand side is equal to right hand side, this proves this property which states that if the rows and the columns are interchanged, then the determinant value remains unaltered. The next property of a determinant states that if any two rows or any two columns of a determinant are interchanged, then the resulting determinant is the negative of the original determinant. That is, we have a determinant of the form as shown, consisting of 3 rows and 3 columns, with column 1 having elements A1, A2, A3, column 2 B1, B2, B3, and column 3 as C1, C2, C3. Now in the determinant on the right hand side, we have interchanged column 1 and column 2, and thus the value of the newly obtained determinant would be the negative of the original determinant. To prove this, we consider the left hand side and find the determinant. Expanding the first row, A1 into B2 C3 minus C2 B3 minus B1 into determinant whose value is A2 C3 minus C2 A3 plus C1 into minus C1, which is A2 B3 minus A3 B2. This gives us a value which is A1 B2 C3 minus A1 C2 B3 minus B1 A2 C3 plus B1 C2 A3 plus C1 A2 B3 minus C1 A3 B2. Now this can be further written in the form minus of B1 A2 C3 minus of B1 C2 A3 plus A1 C2 B3 minus of A1 B2 C3. Similarly, plus C1 A3 B2 minus of C1 A2 B3. Now this equation can be further rewritten in the form of minus B1 into A3 A2 C3 minus A3 C2 minus A1 into B2 C3 minus B3 C2 plus C1 into B2 A3 minus B3 A2. Now this equation can be rewritten as in the determinant form of third order as B1 A1 C1 B2 A2 C2 B3 A3 C3, which is equal to the right hand side of our example. This thus proves that if any two rows or columns are interchanged, the resulting determinant is negative of the original determinant. The next property of a determinant states that if two rows or two columns in a determinant are identical, then the determinant is equal to 0. For example, if you consider or a determinant whose first row and second row are identical, then the value of this determinant would be equal to 0. We prove it by taking the left hand side determinant whose value would be, expanding the first row, we have a1 into b1 c2 minus c1 b2 minus b1 into a1 c2 minus c1 a2 plus c1 into a1 b2 minus a2 b1. Now opening the brackets, we have the value as a1 b1 c2 minus c1 b2 a1 minus b1 a1 c2 plus b1 c1 a2 plus c1 a1 b2 minus c1 a2 b1. This shows that all the values would be getting cancelled, and thus we would be having left hand side equal to 0, which is equal to right hand side, and thus we have proved that if any two rows or two columns are identical, then the value of that determinant is equal to 0. The next property of a determinant states that if all elements are multiplied by the same number of a column or a row, then the resulting determinant is also the product of the determinant and that number. For example, we consider a third order determinant whose value of determinant is equal to d, then the value of the second determinant whose first column elements are just multiple of the elements of column 1 of the first determinant, then the value of that determinant would be k, that is the constant to which we have multiplied the first column elements of first determinant, into d, which was the determinant value of first determinant. Next we consider a numerical problem that would be utilizing the properties that we have discussed in this earlier section. So now the value of this determinant can be obtained by utilizing the property which states that if all the elements of a row or a column are multiplied by the same number, then we can write the determinant as delta equal to, now taking a square common from the first column, we have the left determinant as 0 b c ab square 0 b square c ac square bc square 0. Similarly, we can take b square common from the second column, and thus determinant becomes a square b square. The values are inside determinant are 0 bc a 0 c, and the third column consists of ac square bc square and 0. Now we can take c square common from the third column again. This gives us a value of a square b square c square into determinant whose value is 0 a b 0 b and c 0. Now again we can take value a common from the first row. This gives us a outside, and similarly b from the second row and c from the third row. This gives us a cube b cube c cube into determinant whose values are 0 1 1 1 0 1 and 1 1 0. Now this makes us evident that the evaluation of this determinant is much easier than the determinant which we had in the problem. This shows that how we can simplify the evaluation of a determinant by the usage of the properties. With this we conclude this lecture.